Okay, so let's talk about theories and hypotheses. A theory is not an unverified hypothesis. It's not a mere guess. It's not a hunch. Oftentimes, colloquially, we'll talk to individuals and we say, oh, that's just a hypothesis. That's just a theory. Well, in science, it's almost completely false, completely opposite of what we mean when we say it normally, or how they use it in everyday conversation. So a theory in science is an interrelated set of concepts that is used to explain a body of data and to make predictions about the results of future experiments. So what does that mean? A set of concepts explaining a body of data and to make predictions. So when we look at theories that have been kind of widely accepted, let's say, for example, the Big Bang Theory. Well, the Big Bang Theory, right, is this idea that the universe was at one point infinitely small and then expanded into what we have today, this universe, the Big Bang Theory. Okay, this is one of those theories that we hear about from a very young age. Well, this theory isn't just someone's guess that, hey, this is what I think happened at the beginning of the universe. When in fact what it is it's based on a lot of concepts, a lot of predictions, a lot of studies that help show that this is highly possible, that the universe came into existence because of this big explosions of sorts. And so this theory stands because it combines these concepts, this body of data, these many publications from different fields, diverse fields, and different experimentations, different studies and correlations, and it makes a prediction about what we can expect. And that's why the Big Bang Theory, evolution theories are still standing strong. It doesn't prove anything. Keep in mind, science doesn't prove anything. It just says that certain things are less likely. Okay, the hypothesis stems from this theory. So this theory stands as an umbrella, and from this theory come these specific predictions called hypotheses. So again, the hypotheses are these specific predictions. Okay, so the scientific method is the method that we use in psychology. It is used in many other fields, including chemistry and physics, and it's the same method that we use over and over and over. You've heard about it. Children from a very young age start hearing about that. And it's the same process. You ask a question, something you want to know. In psychology, we deal with the mind and behavior, so we may ask questions of why are less people less likely to help in an emergency situation, or when are people more likely to conform to others around them, right? So see, these are some of the questions that we have. So from this research question, this curiosity, and by nature humans are curious, so we start with this broad question, and from there we make a very clear prediction. A famous experiment is called the bystander effect in psychology, and the prediction is very clear here. Their research question is, why is it that there's less help when there's many more people around in an emergency situation? So when you have these big events or public tragedies, emergencies, and there's a lot of people around, why don't they go and help? Why don't these individuals go and help out? And so that was the research question that these psychologists had. And then they state a hypothesis. I believe that the more people that are around in an emergency situation, the less likely that individual in need of help will get help. Okay? So notice that in my hypothesis, it is a prediction, and it's something that I can prove false, that I can show that it's unlikely. So you ask a question, you make a prediction, then you test that hypothesis. We're going to talk about the different ways that you can test that hypothesis. Finally, you analyze the results and you make a conclusion. If the results support your hypothesis, then you write up the report and report your findings for peer review. At this point, it could be one study. I may have to answer a couple more questions, but I send it to a journal that gets peer reviewed, Okay, and my peers, who am I talking about? Other scientists that are studying something I do. Other scientists that are respected, that know how to use science and the methodology. They're the ones that look at my paper, and they're the ones that look at my methods and say, okay, this is some valid research. Or they might suggest that, no, I'm sorry, you didn't run the science correctly. And they would reject it. If your results do not support your hypothesis, then you revise your hypothesis and you repeat. So maybe you had the hypothesis wrong. Maybe you tested it wrong. So you go back to this drawing board. You may still be interested in the question and say, you know what, maybe our hypothesis is wrong, or maybe the way we tested it didn't accurately get to the truth of the matter. So that's the scientific method in a nutshell.